and specifically talked about the genetic trend for increased milk in many of the beef breeds, and the idea that more moderation in milk may be reduce enterprise risk in the face of increasing risk of drought over time. So in this video, I'd like to talk a little bit about mature size, muscle, and growth as it affects commercial cow-calf efficiency. It needs to be clear that these comments will be specific to commercial operations, with the assumption that commercial indicates an operation that tries to minimize expensive inputs, so low annual feed costs, and rely primarily on forage for nutrients. So this is a data set of the genetic trend for yearling weight in 7 different breeds. And again, I've just selected a handful of breeds here. Keep the slide from being too busy, but these genetic trends have been adjusted across breeds, and so they should be comparable from one breed to the other. For this presentation, I'm not interested in the ranking. What I'm interested in is the genetic trend over time. And it should be apparent that the beef cattle industry, you might consider this to be a never-ending arms race for growth. And certainly we have aggressively selected for growth for the last 25 years, and actually probably going back quite a few years beyond that. How does that influence breeds and cow size? Fortunately, we have the tools available today where we can actually hold cow size at moderate level while increasing growth. However, it sort of complicates the issue when we also increase the muscle and perhaps visceral organ mass at the same time. And so I'll show you how that works. First of all, let's just take a quick look at a couple of breeds that publish phenotypic trend for mature weight. And this is the Hereford breed, and you see the phenotypic trend for mature weight in that breed up through 2014. And what you see is a pretty aggressive selection for increased mature weight, and then it's kind of leveled off since the 1990s, although it continues to creep up or increase gradually over time. This is mature weight EPD, so this slide, rather than being mature weight in pounds, this is the genetic trend for the actual EPD in the Angus breed. And what you see there is a gradual increase also since 1990 in mature weight. The interesting thing about this genetic trend, the trend for mature height, has been flat since 1987. What that says is that the cows are not getting taller, but they are getting heavier over time, and a gradual increase. Well, how does that work, and how can that be? This slide just kind of shows you the latest results from the Meat Animal Research Center GPE project. I think this is the cycle 7 data, as I recall. But you see here, it's interesting that Hereford Angus and Red Angus crossbred cows, this is the F1 crossbred cow data, if they were sired by Hereford Angus and Red Angus bulls, actually weighed more recently than Simmental crossbred cows, than Limousine, and Charolais gelding. I'm not sure that a lot of producers maybe recognize that. You can't think about the beef breeds the way we did 20 and 30 years ago. They have changed a lot. Okay, so this is the similar kind of data with the crossbreed adjusted genetic trend for ribeye area. Since we've had the tool to do this, muscling has been aggressively selected for in the last 20 to 30 years in the cattle industry, and that continues today. In fact, we're selecting for muscle more aggressively now than we were back in the 1990s. What I want to challenge folks with, particularly with the likelihood or possibility of increasing incremental weather, drought, if you will, in particular, is this a good thing? And how might this influence commercial cows in terms of their efficiency? That's what I've asked here at the top of this slide. How will continued aggressive selection for muscle impact commercial cows' matching ability? And the answer is that it's not real clear. Thought maybe it might increase maintenance requirements like we talked about with milk dramatically. Turns out, as we dug into this, it does not appear to. There probably will be a minor increase in maintenance requirement over time. It will increase mature weight. That's kind of interesting, but I'll show you in just a minute how that works. More muscle equals less fat at the same live weight. You can't have more muscle without having a leaner animal at the same live weight. And that's basically the bottom line. I'll show you a graph here in just a minute. Obviously, the beef industry is selecting for muscularity to try to improve carcass yield and reduce yield grade 4s and 5s. And there's a heavy discount that goes with those higher yield grades, and rightfully so. However, there may be a cost to the cow herd. This literature review by Dr. Mike Test, published in 2002, as he summarizes the undesirable associations between maternal traits and retail product appear to be mediated through fat thickness. In other words, according to Splan and others, lower adipose composition is associated with older age at puberty, lower conception rate, and lower calving rate. Let's say we use the body condition scoring system. Hopefully most producers are familiar with that system by now. And here in Oklahoma, we suggest our producers, they calve their cows in about a body condition score 5. Okay, well this graph represents the percent protein across a wide range of live weight. Percent in the red line is percent protein or muscle tissue. As the cow increases in weight, fatness, increase in condition score or whatever, the percent of muscle in her body actually gradually declines. And that's because the percent of her weight that is fat is dramatically increasing. Hopefully that makes sense. Well, those lines crossed right there at about a body condition score 5. Again, that's where we recommend producers try to have their cows in somewhere around a body condition score 5 at the time of calving, and that would give her the best opportunity to breed back and maintain a 365-day calving interval. The problem is if we continue to select for muscle, what you do is you essentially raise the level of the red line, higher percent muscle or protein, and that means the yellow line has to come down. Okay, something has to give, and so you have the same slope, but the yellow line is lowered. If this is a body condition score 5 cow, the yellow line here might be at about, let's say, 15% body fat. Well, now 15% body fat is clear over here on this graph. As you can see, if the x-axis on our graph here is live weight, in order to keep that cow fertile or maintain the same pregnancy rate or weaning rate in that cow herd, they're going to have to weigh more. You have to make them heavier to get to the same fat composition, and that's how that works. So we've asked the question, do bigger cows wean bigger calves in restricted environments, in other words, in commercial herds? So we've gathered some data on several herds, and I'm just going to show you one here right quick. This graph represents weaning weight over here on the y-axis. You've got cow weight down here on the x-axis. So wide range in cow weights. The blue line represents the slope or the regression equation. First of all, you see that it looks like somebody nailed that with a 12-gauge shotgun, which tells you that there's not a real strong relationship between calf weaning weight and cow's body weight in this commercial cow herd, which is interesting. You would think that it'd be more highly related, but in this case it was not. Okay, so the slope of this line is represented right up here, and if we multiply that by 100, what we would get is 6 pounds increase in calf weaning weight for each 100 pounds of increased cow weight. Okay, now I want folks to notice that there's going to be some small cows that are really efficient. Here's a good example. There's going to be some small cows in a herd that aren't very efficient at all. And there's going to be some big cows that do a really good job. There's going to be some big cows that you wish you would have sold 5 years ago. And that's what's represented here. Individual cow efficiency is not specific to small cows or big cows. There's variation in each. However, 6 pounds that go with each 100 pounds of cow weight is not very exciting. In fact, we looked at several data sets that were already published or ones that we generated, and what we found was the range. We found 6 pounds. This one said 4 pounds, 6 pounds, 6 pounds. Here's one data set from Arkansas that indicated that they saw 15 pounds increase in calf weaning weight for each 100-pound increase in cow weight. That one was the most responsive to cow size. Problem is, Dr. Doy and I have evaluated that from a cost standpoint, and it's in 2011 enterprise costs, we estimated that it costs about $42 to keep that extra 100 pounds of cow weight around. And if you're only getting, say, 4 to 15 pounds of calf weaning weight, and it costs 42, just not a very good trade-off. Final thing then, growth and feed intake. How might this influence commercial cows? Here's that genetic trend for yearling weight. As I mentioned earlier, we're really aiming for the hat band in this trait in the cattle industry. And what we find, if you review the literature, is that increased feed intake and gut capacity results in increased visceral organ mass, just like milk does. And so this trait should gradually increase maintenance requirements over time also. It also increases appetite in cattle. And so what we're doing is making commercial cows that have a greater appetite. It's interesting to note that the GI and liver make up less than 10% of the cow's body mass. On the other hand, they use 40 to 50% of total energy expenditure in a beef cow. And so it's really important characteristic. So what we've been doing, we have been teaching guidelines, experts throughout the industry, extension folks, so on and so forth, based on conditions that reflect a nutrient status that maximizes reproductive performance. And so major limitations focus on short-term effects, little consideration for those long-term implications. Tough times don't last, but tough cows do. And really that's the point of this and the previous conversation, is that we probably need to aim more for the middle in terms of these characteristics for commercial cow operations. If we need more feed yard growth, feed efficiency, and so on, we might be better off getting that through a terminal sire. How can we improve that match without increasing inputs? There's some real simple things that producers can do to improve on that dramatically over time. Well, I say over time. I don't know about dramatically, because fertility is low inheritability. It is heritable, but it requires a long-term commitment. And so what our group has been telling our producers to do is aim for more moderate, mature size, milk and muscle. Cull open cows, be willing to challenge them. Don't be afraid of some years you're going to have a marginal pregnancy rate. That's probably not a bad thing all the time, because those cows will tell you which ones match their forage resources and those that don't fit very well, and they can cull themselves. Resist the temptation to gradually modify the environment in order to maintain the same level of reproduction over time. Keep only early-born heifers, keep only early-bred heifers, buy or keep bulls out of cows that always calve early. Those three things all tell you that something or several things, many things perhaps, went right. Okay, they went well, and those animals have a higher likelihood of matching your forage resources, because they were able to become pregnant early in the breeding season. If you do that year after year, for 10 or 15 years, you'll wind up with a cow herd that's a good match to your forage resource. We're not going to go into all the tools available in this presentation, but there are tools available, and they just need to be used and made a priority in selection. And perhaps some moderation is suggested relative to selection for carcass characteristics. We need to improve those too, but in face of reduced forage availability and forage quality over time in the long run, more moderation in these characteristics will be helpful and reduce enterprise risk. In terms of improving reproductive efficiency, I just give you the same list I did for the commercial cow-calf operations. Find a source of seed stock, purchase bulls from a breeder that puts priorities on those economically relevant traits, that culls their open cows, that keeps early-born heifers, keeps early-bred heifers, puts the environmental pressure on their cattle, and so that over time they too weed out the cows that don't match. They can be productive and fertile in their environment and it's similar to yours, you can be confident that they will go home and be efficient cattle in your operation. One last thing, and it's kind of similar, but that's purchase bulls out of cows that are managed like yours are or worse. Well, that or worse may not be the best term there, but the idea, again, is to purchase bulls out of cows that have been challenged and have made a living and be very efficient on range resource or forage resources similar to your own. Okay, so in summary, no strong evidence that commercial cow efficiency has improved. We talked about in the first video from a commercial cow-calf perspective. I said the industry is on an unsustainable path, and I think from a commercial cow-calf perspective, that would include muscle, milk, and growth. Cows are not getting taller. They are getting bigger, however, bigger in terms of weight, and we can't seem to get enough milk, muscle, and growth. The result, I mentioned in the last video, feed inputs cost per cow-calf unit are probably increasing while production is not. And those old and new tools are available, but those are going to need to become a priority in selection decisions and not simply considered secondary traits. Hope you've enjoyed the video, and thank you for watching.